Question 10.49 says, consider this reaction. So I have 2 moles of ammonia gas in equilibrium with 1 mole of nitrogen gas and 3 moles of hydrogen gas. And part A says, write the equilibrium constant expression. So the equilibrium constant expression is going to be equal to the concentration of the products to the power of their stoichiometric coefficients divided by the concentration of the reactants to the power of their stoichiometric coefficients. So in my numerator, I'll put concentration of nitrogen. Since there's no number in front of it, we assume it's a number 1, so I don't have to put any exponent there. Then for my hydrogen, since the stoichiometric coefficient is 3 in front of it, I'm going to cube that, and I divide by the concentration of my reactant or starting material, which is ammonia, and that will be squared. So there's my equilibrium expression, and then in part B, it says, what is the numerical value for the value of the equilibrium constant for the reaction if the concentrations at equilibrium are 0.20 molar, so I have 0.20 molar ammonia, 0.30 molar nitrogen, and 0.50 molar hydrogen. So all I have to do is plug those numbers into my equilibrium constant expression. So the concentration of my ammonia is, my nitrogen is 0.30, so 0.30. I'm just going to leave out the units because our textbook generally leaves out the units in these questions. Multiplied by the concentration of hydrogen, which is 0.50, and I'm going to cube that. I divide it by the concentration of my ammonia, which is 0.20, and I'm going to square that. So when you punch all of that into your calculator, so 0.3 times 0.5 cubed divided by 0.2 squared, you end up rounding up to something around 0.94 as being equal to the equilibrium constant value for those concentrations. So this gives you an idea of how to write an equilibrium constant expression and how to determine an equilibrium constant given the concentrations of the reactants and products in a equilibrium.